Hi, good day to you all. Welcome to another physics class. So we're still continuing on the topic specific heat capacity. So we just solve more questions on it for proper understanding. So now let's look at this question. A car, let me stay here. A car of mass 1,000 kilograms. I want to be writing the parameters as I read out the question. So now let's look at this. The mass of the car is what? 1,000 kilograms. It's traveling at 72 kilometers per hour. That simply means this is the velocity. But remember, this is a kilometer per hour, so we have to convert it towards meter per second. So here we have velocity equals 72 kilometers per hour. It's brought to rest by applying brakes, assuming that the kinetic energy of the car becomes transferred to internal energy in forced steel brake drum of equal mass. Find the rise in temperature. That is, we don't know the change in temperature. If the total mass is 20 kilograms, that is the mass of the drum, is 20. And the specific heat capacity of the steel is 450 joules per kilogram per Kelvin. And the work done is equal on all four drums. So now, let's first of all start with this velocity. We have to convert it to meter per seconds. We have to convert this velocity in kilometer per hour to meter per second. So how do we convert to meter per seconds? It says 72 times 1,000 over 60 times 60. 0, 0, 0, 0. So here we have 720 over 36. That will give us 20 meters per second. Let me adjust the lens. So, now that we've calculated our velocity as 20 meters per second, so what next? Remember that here we're told that the kinetic energy is now transferred to the internal energy. Now the kinetic energy here is now transferred to our heat energy, which is what? MC change in theta. So if you want to analyze this out, we are going to say, what is the formula for kinetic energy? Half mv squared equals to MC change in theta. Half, what is the mass of the car? 1,000, velocity 20 times 20 equals, what is the mass of the drum? 20. Specific heat capacity 450, and we are looking for our change in temperature. Is that analysis okay? We are looking for the change in temperature. So now let's go. So here 1, 2 here thing. So what do we have all together here? This one is 10,000. So we have 200,000. Here, multiply this one. This time, this is 90. 90, change in temperature. Divide both sides by 9,000. Divide both sides by 9,000. So our change in temperature, here's the calculator. Our change in temperature will be 200,000. 200, 1, 2, 3, divided by 9,000. And that will give us a total of 22.22 degrees Celsius. 22 degrees Celsius, or you just say Kelvin, either way. Do you understand the illustration? Now we're given the parameters here, we write them out. Now we're told that the kinetic energy is transferred to internal energy, which is the heat energy. And the formula for heat energy is what? MC change in theta. So here we are going to equate the two together. So half mv squared, find it out, equals to this because we are looking for the change in temperature. Is that understood? Let me adjust the lens again. I don't know what's happening. Doesn't want to be adjusted, it's Steve. Okay, I hope you've seen a clearer picture of what I just calculated. So now let's go to the second question. Let me rub it off. Okay, so now let's look at this. Now the question says, find the mass of a steel with specific heat capacity of 330 joules per kilogram per Kelvin. If the temperature is raised from an immersion heater of 15 degrees Celsius to 60 degrees Celsius with a current of 16.77 amperes from 50.6 volts, and the time being is 1 hour 15 minutes. Let us write out the parameters. Let's start with this. The specific heat capacity of the steel is 330 joules per kilogram per Kelvin. So here the temperature is raised. What is the change in temperature? That will be from 15 to 60. So that will be 60 minus 15, and that will give us 45 degrees Celsius. So here, what is the current? The current high is 16.77 amperes. The voltage, V, 50.6 volts. And the time, remember your time has to be in seconds, but here we're given 1 hour, 15 minutes. We are given 1 hour, 15 minutes. So we have to do the conversion. Let's first of all convert the 1 hour to seconds. So 1 hour will be 60 times 60. We have 3,600 seconds. Now the 15 minutes, convert it to seconds. That will be 15 times another 60, and that will give us 900 seconds. So our time will give us the total of 3,600 plus 900, and that will give us a total of 4,500 seconds. Can you see the way I converted my hours to seconds? Then the minutes to seconds, and you add the two together to have your 4,500 seconds. Now our time is standard. So let's go back to the question. Remember here that its loss is from the heater equals to heat gain by the steel. So here now, where is the heater? Because current is involved, that will be IVT equals to the heat, yes, to the heat energy. So here, what is our current? 60.77. What is our volt? 50.6. Our time, 4,500. What is the mass? That is what we are looking for. M. Specific heat capacity, 330. And what is the change in temperature? 45. Is that taken? Can you see the way I analyze my parameters? So now let's multiply it out. Let's start. 16.77 times 50.6 times 4,500. That will give us a total of 3 million. Okay, let me write it out. 3818529. Now multiply 330 by 45. 330 times 45. That will give me 14,800 M, because it's the mass we are looking for. So divide both sides by 14,850. Divide 3, 8, 1, 8, 5, 2, 9. Divided by 14,850. So here we'll be having 257 points. So our mass will be equal to 257.14 kg, because it's the mass we are looking for. Yes. Is that taken? Any question, confusion? All right. See you next class. Take care. Bye.